This is a one-sample hypothesis test. It is a proportion problem. A college points out that at most 50% of the college students drink coffee every day. You took a random sample of 300 students and found that 200 of them drink coffee every day, 15% significance level. Should we trust the at most 50%? So this is a proportion problem because you have two numbers. The first one is sample size. So n is equals to 300 students, and then the number of success, x is equals to 200. And then you have to set up your sample proportion, p hat, that is equals to x divided by n, which is 200 divided by 300. Do not reduce that. Do not reduce the fraction. Do not convert this to decimal. And in some textbook, they instead using p hat. So the hat, do you see the hat above the p? That is in statistics. Every time you use a hat, that means estimation. So estimating p hat means a sample proportion. Estimating p. So P is the population proportion, or you call that the true proportion. If you have a P and a hat, that means an estimation, a sample proportion. In some textbook, they don't call that the P hat, they just call that a P prime. I prefer to use hat because hat means estimation. And then, what else? You have the at most 50%, so that is the P naught equals to 50%. All right. That's all the givens, and then you have to set up your H0 and HA. So by the way, this is how do you know it is a proportion? Again, you have two numbers. You have a number of success out of the sample size. Proportion problem is just that easy. And then you set up your H0 and HA. So H0 is at most. So at most is the true proportion is less than or equal to 50%. And then HA, they did not give you HA. I would just take the opposite, greater than 50%. So either they told you the truth or they lied to you. And then the next step is you have to calculate the test statistics, which is z equals to p hat minus p naught divided by the square root of p naught 1 minus p naught divided by n. And then you also need to report the p value. Okay, so let's do this in my calculator. We go to stat, and then you go to test, you start at edit, right? And then you go to test, and then this time you select one prop z test, which is in line 5, one proportion z test. And then you have a 0.5. And then the this is 200 out of 300. And then you have a greater than in the HA. So be very careful. This, you must get this one right, because the greater than in HA that determines the p-value. Greater than is a right side, the p and that means the p-value and the rejection region, they are both on the right side. And then you have to you either click calculate or draw, right? So you click draw, you get a picture of the test statistic and the p-value. You click calculate, you get the answers in the menu. So you have test statistic equals to 5.77 3 or 4. So that is 5.77 4. This is test statistic. And then the p-value, this one is 3.88 times 10 to the negative 9. So do you see E negative 09? This is scientific notation. So scientific notation is for you to write a very long number in a very compact form. So if you want to put this back to a decimal, you have 9 zeros. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 and then 3, 8, 8. Every time you see this kind of number, so that means the p-value is very close to 0. We are happy because we can reject the null hypothesis. And then if you click the draw option, they will give you a graphical representation of the test statistic and the p-value. So you get a bell curve, and then you have the mean right in the middle. The 5.44, so it's all the way on the right. I don't want to draw this all the way on the right because you won't see the p-value. So if you zoom in a little bit, the 5.44 is so far on the right. 5.774, not 44. 5.774 is so far on the right, is pushed all the way to the right, such that the p-value is very tiny. So if you look at this on your calculator, you click the draw option, you won't see any region under the curve. It is not, you cannot say it is not there, it is there all the way to the right, but it is very small. I am sure that using your TI84, so when you look at the p-value, they will just say the p-value is equals to 0. And then what about the rejection region? The rejection region 15% is on the right because we have a greater than. So 15% is way bigger than that. So the cut is like right here. So the cut is like right here. And then the rejection region is over there. So since the p-value is inside the rejection region, we reject the null hypothesis. So what about this red z? So the red z is equals to inverse norm. And then you input the 15%, 0, 1 due to standard normal. Let's see what that equals to. So if you go to second vars, and then choose inverse norm, you have 0.15, mean is 0, standard deviation is 1, and then you click paste, that is negative, positive on the right side, so that is positive 1.036, 1.036. If you want to use the z to make a decision, you will say 1.036 is less than 5.77. Therefore, you reject the null hypothesis using the z. If you want to use the p-value, you say the p-value is inside the rejection region, or you say p-value is less than alpha. So the p-value is less than alpha. Therefore, we reject the null hypothesis. So it's way less than alpha, which is 15%. So therefore, we reject H0. And then we say HA is true. What does that mean? That means the college lied to you. HA is true. That means less than 50% students drink coffee every day. All right, so this is a reject, and then the next step is I would like to use a confidence interval to support myself. So let's do that in a different colors. So confidence interval, I have a 15% alpha, right? So I have a 15% significance level alpha. So that means I will be using an 85% confidence interval because 85 plus 15 is equals to 100%. And then the formula is you have the point estimate p hat plus or minus z half alpha, and then you have a square root p hat 1 minus p hat divided by n. Oh, by the way, why do we have to use z? I will answer this question in a minute. Let's calculate the confidence interval first. So we go to stat, and then we do one proportion z interval that is in line A, the letter A, one proportion z interval. Select that one prop z in. Oh, I have to on my calculator I have to erase this result first, and then we go to stat test one prop z in, and then this is 200 out of 300, and then the confidence level is 0.85, and then you calculate. So when you hit calculate, you have on your TI84 plus you have 0.62749, and then 0.705, 0.70585. Oh, by the way, why is this in Z? Because here is why. Because the sample proportion follows normal distribution with P. What is P equal to? The P is equals to 50%, so you roll 0.50, and then the standard error is the square root of P 1 minus P divided by N, and then you have the square root of, so let me calculate that for you. So you have the square root of 50%, 1 minus 50%, 1 minus 0.5 is still 0.5, and then you divide it by the sample size is 300. So this one you have 0.0287. 02889, not 87, 89, 0289. All right, so that's why you use the Z over there. Okay, back to the business. Explain the confidence interval to me. Explain, not verify. Explain. So explain means we are. Before you explain, you can round this up. So you can round this up to 63%, because that looks much cleaner. 71%. So we are 85% confident that the true proportion of students who drink coffee every day, of college students who drink coffee every day daily falls between 63% and 71%. What does that mean? You are trying to estimate the true proportion P. We are 85% confident that the true proportion is between 63% and 71%. So the truth is between 63 and 71. What did you claim in the H0? In the H0 in this problem, they claim at most, right? So they claim at most. So they have H0 P at most, so less than or equal to 0.50, which is 50%, right? Is 50 inside or outside? 50% is outside, so this is outside the confidence interval. So you claim that this is the truth, but what you claim is outside, so your number is not the truth then. So H0 is not true, then you reject H0. For the confidence interval, in case the text, in case your homework asks you to sketch a picture, so here is the picture. So you have to sketch a bell curve, and then you have a lower cutoff and upper cutoff. You have 85% right in the middle, and then you have the lower limit 0.62749 and upper limit 0.7585. What about the middle? What is in the middle of the curve? In the middle of the curve, you have a p hat, because that is your point estimate. Your p hat is equals to 200 out of 300. And they might want you to put this in decimal. All right, so before we end this video, let's take a look at the calculator, because mine is not an exactly TI84. So if you are using a TI84 or 83, this is what you're supposed to see. So the first one is you go to stat test, right? So you go to stat, and then you go to test, and then you select the one proportion Z test, and then you input the proposed proportion 0.5, and then the number of success, the sample size, and then you have to select the correct symbol for your HA, because that determines the left side, right side, or two side. Not equal is two side, less than is left side, greater than is right side. And then if you click calculate, you get the test statistics and the p-value. So this p-value, so this is 3.89 times 10 to the negative 9 power. So this is less than 0, because that is so small. So not less than 0, it's less than alpha. So this is less than alpha because the p-value is so small. So that's why you reject H0. And then if you click the draw option, you see that the 5.7735 is like all the way on the right, 7735, and then the p-value is so tiny over there, you cannot even see it, and then they say the p-value is equals to 0. And then for the confidence interval, you also go to stat, and then you go to test, and then you select the one proportion Z interval. And then you input the X and the N, and then make sure you select the correct confidence level. Once you calculate, and then you will see the upper limit and lower limit. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, subscribe to my channel. See you all in the next one. Signing off for now.